Hello students, in last session chapter number 7 coordinate geometry completed. In this session we start a chapter number 5 arithmetic progression. In arithmetic progression, first of all we see the basic terms and condition, basic theory. Arithmetic progression is one type of sequence. Now what is sequence? First of all we discussed about the sequence. Sequence: when some numbers occur in a definite order following some definite rule, the numbers are said to form a sequence. Now let us take examples for a sequence. Every sequence does not possible to be a arithmetic progression. Arithmetic progression is simply denoted as a AP. AP is called arithmetic progression. When some numbers occur in definite order following some definite rule, the numbers are said to form a sequence. Every numbers are called terms of sequence. Let us take different examples for the sequence. First is 2, 4, 6, 8 up to infinite. It is a one type of sequence. Obtain each number by adding 2 to its previous number. 2 plus 2 gives 4. 4 plus 2 gives 6, 6 plus 2 gives 8, 8 plus 2 gives 10 up to infinite. In this sequence, each number is obtained by adding 2 to its previous term. Now we see the second example. Second is 15, 10, 5 up to infinite. Now see what happened here. Here 15, 10 is obtained by subtracting 5 to its previous term. 5 is obtained subtracting 5 from its previous term. It is an example of sequence. In this sequence, each number is obtained by subtracting 5 from previous number. It is again example of sequence. Now a third number. Third, suppose let us take example for the multiplication. 4, 4 2s are 8, 8 2s are 16, 16 2s are 32 up to infinite. In this sequence, each number is obtained by multiplying 2 to previous term. Next, the fourth number. Use a division. 16 8, 4, 2 up to infinite. Here the term 16. Next 8. 8 is obtained by divide 2 its previous term. 8 divided by 2 we get 4. 4 divided by 2 we get 2. 2 divided by 2 we get 1. In this sequence, each number is obtained by dividing 2. From the previous number. Hence, the 4 examples are of sequence. All 4 are not an APs. Now, what is AP? Let's see the definition of arithmetic progression. Arithmetic progressions. Arithmetic progression is also one type of sequence. Arithmetic progression is a sequence in which each term is obtained by adding some number to the previous term. But we accept the first term. We take a first term as any number, then we add some specific number to the previous term and we get arithmetic progression. In arithmetic progression, some specific number whenever we add in a previous number is called common difference. This specific number is called common difference. There are 3 types of common difference. Common difference may be positive, negative or 0. It can be negative, positive or 0. It is a definition of arithmetic progression. Let us take example for the arithmetic progression. In first 4 sequences, the first number and the second number is the example of arithmetic progression, but third and fourth is not example of arithmetic progression. First example is, take a one number, any one number. Suppose 75 is one number. Now we add one specific number, suppose 3. 75 plus 3 gives 78. 78 plus 3 is 81. 81 plus 3 which is 84 up to infinite. It is example of arithmetic progression, AP. Second example, suppose 100. We add minus 10 to this number. Minus 10 to this number we get 90. Add again minus 10, 80. Then 70 up to infinite. In first AP we have to add plus 3, plus 3, plus 3. In second example we have to add minus 10, minus 10, minus 10. Here the specific number 3 minus 10 is called the common difference. It can be positive, it can be negative, or also 0 is also possible. Suppose each and every terms are 5, 5, 5 up to infinite. We can add here plus 0 plus 0 plus 0 and we get arithmetic progression. These are 3 examples for the arithmetic progression. Now there are 2 types of arithmetic progression. One is finite AP and second is infinite AP. Finite arithmetic progression and the infinite arithmetic progression. In the finite arithmetic progression, number of terms in the AP are finite. It is countable. In finite AP, number of terms are finite. We know the last term of this AP. Let us take example for that. Suppose first example. First 100 natural numbers 1, 2, 3 up to 100. It is called finite AP in which the common difference is 1. The second example. Multiples of 3. 3, 6, 9, 12 up to 99. It is also a finite AP in which some specific numbers are available in AP and we are able to count this number. How many numbers the AP can contain. It is called a finite AP. Now the second, which is infinite AP. In the infinite AP, there are lots of number and it can't be finite. If arithmetic progression is not finite, it contains infinite terms. It is called infinite AP. Let us take example for infinite AP. For the infinite AP, last term does not define. Suppose 2, 4, 6 up to infinite. Second example is 10, 20, 30 up to infinite. Third example is minus 5, minus 10, minus 15 up to infinite. They are called infinite AP. In finite AP, we know 3 terms. First term A, last term and a common difference. But in infinite AP, we know only 2 terms. The first term A and the common difference D. There are 2 types of AP, finite AP and the infinite AP. Now we discuss about standard form of arithmetic progression. Now let's see the standard form of arithmetic progression. Standard or general form. Standard or general form of an arithmetic progression. As we know, what is finite AP and what is infinite AP? When small a is first term and small d is common difference, then the general form of an AP is given by A, A plus D, A plus 2D, A plus 3D up to infinite, in which A is a first term and D is the common difference. It is called general form of an AP. Whenever the AP is a finite, its general term is called the nth term. Here A is equals to first term, D is equals to common difference. Common difference is obtained by subtracting two consecutive terms of an AP. After that, we discuss about arithmetic mean. Suppose let us take example for that. First term A and common difference D. 5, 20, 35, 50 up to infinite. It is a AP, so that first term here, first term A is equals to 5 and the common difference D is obtained by subtracting second term with the first term. 20 minus 5 is equals to 15. 20 plus 15 gives 35. 35 plus 15 gives 50. There are different types of examples of an AP in which we need find the first term and the common difference. Now see the arithmetic mean. Arithmetic mean. Whenever three terms form an AP, when three terms A, M and B form an AP, as well as they are three consecutive terms of an AP, then the middle term M, then M is called arithmetic mean of A and B. The arithmetic mean is obtained by difference of the consecutive term. Second term minus first term, M minus A is equals to B minus M. Shift minus M right hand side to left hand side and minus L left to right. M plus M is equals to A plus B, where M plus M is a 2M is equals to A plus B, where M is equals to A plus B upon 2. Here the arithmetic mean is the average of two terms A and B. Here the arithmetic mean is obtained by average of two numbers A and B. It is called arithmetic mean. Now keep in mind one note. If A, B and C are three consecutive terms of an AP. Then whenever 3 consecutive terms of an AP are given, we can subtract one number from 3 numbers, we can add one number from these 3 numbers, or multiply or dividing. They are also form an arithmetic progression. Then first A plus K, B plus K, C plus K are consecutive terms of an AP. For that, suppose I will take here one example, 4, 8 and 12. 4, 8 and 12 are 3 consecutive terms of an AP. If I will add plus 2 and plus 2, then what happened here? 4 plus 2 is 6, 6 plus 2 is 8 plus 2 is 10, 12 plus 2 is 14. It is also arithmetic progression. In the first number, the common difference D is equals to 4. In the second number also the common difference is a 4. They also the 3 consecutive terms of an AP. The second number, whenever we subtract one number from the 3 consecutive number, the new numbers always be the consecutive terms of an AP. Like this, A minus K, B minus K, C minus K are consecutive terms of an AP. Suppose 4, 8 and 12 is the example. If we subtract 2, 2, 2, minus 2 and minus 2, we get new term 2, 6 and 10. Is it also arithmetic progression? Yeah, it is also arithmetic progression because the difference between 2 consecutive terms are equal, 4 and 4. 2, 6, 10 also the 3 consecutive terms of an AP. Now third, AK, BK, CK. If we multiply K with the 3 numbers, again they already in arithmetic progression are consecutive terms of an AP. For that, again we take same example. If we multiply these 3 terms by 2, 4 2s are 8, 8 2s are 16, 12 2s are 24. Here the common difference will be changed. The common difference is here D is equals to 8. We are adding 8, 8, 8 to its previous term and we get next to next terms. The last is for division. A upon K, B upon K and C upon K are consecutive terms of an AP. For that, we divide these 3 numbers by 2, divide by 2. We get 2, 4 and 6. Yes, they are in arithmetic progression. Whenever 3 numbers are given, if we add some number, subtract, multiply or divide, we obtain 3 new numbers, form an arithmetic progression, and also they are consecutive terms of arithmetic progression. It is a simple basic information about the arithmetic progression. Keep in mind the standard form of arithmetic progression: A plus D, A plus 2D, A plus 3D up to infinite, in which the first term is called as a small a and second term it is called A plus D. For the arithmetic progression from A plus D, A plus 2D, A plus 3D up to infinite. The first term is A. First term is equals to A. Second term A2, it is A plus D. Third term A3 is equals to A plus 2D. Fourth term A4 is equals to A plus 3D. Each and every term is obtained by adding some specific number to its previous term, or A is equals to A1. A1 is the first term. A2 second term is obtained by first term adding common difference D. Now third term A3 is obtained by A2 plus D. Fourth term A4 is obtained by common difference D to this previous term. It is called a general form of an AP. If you are not able to understood directly, let us take this example: 5, 20, 35 and 50. 5, 20, 35 and 50. The first term A is 5, so A1 is equals to 5. Now second term A2 is obtained by common difference D adding 50, A1 plus D, where A1 is a 5 and the common difference is 50, and we get 20. The next term, third term, is obtained by A2 second term plus D, where second term A2 is 20 and common difference D is 15, and we get 35. Same way fourth term is equals to A3 plus D is equals to A3 is 35 plus 15 is equals to 40. It is first way to find the terms of an AP whenever we know the first term and the common difference. Again, there is a second way whenever we know the first term and the common difference. The first term A is equals to 5 and the common difference D is equals to 15. Using A plus D, A plus 2D and A plus 3D, A1, A2, A3, A4, where A1 is also A is equals to 5, A2 is A plus D, where A is a 5 and D is a 15 is equals to 20. A3 is a plus 2D, where A is equals to 5, 2 into D is a 15. 15 to 30, 30 plus 5 which is 35, which is our third term. Same way the fourth term A plus 3D is equals to 5 plus 3 instead of D is 15. 5 plus 15 3 is 45 and we get 15. It is our fourth term. There are two ways to find the terms of an AP using A plus D, A plus 2D, A plus 3D, using A plus D, A2 plus D, A3 plus D. Whenever we know the first term A and the common difference D. Now here the basic information is completed. Let's see example from our textbook. Let's see the examples from textbook. Now we know what type of basic information about the arithmetic progression. Example 1. For an AP, 3 upon 2, 1 upon 2, minus 1 upon 2, minus 3 upon 2, up to infinite. Write the first term A and the common difference D. It is already arithmetic progression is given. We not need to check it is AP or not. It is already AP. The first of all, write the given AP. Given AP, 3 upon 2, 1 upon 2, minus 1 upon 2, minus 3 upon 2 up to infinite. The first number is called first term. First term A is equals to 3 upon 2. To find a common difference, subtract first term from the second term. 1 upon 2 minus 3 upon 2. Take 2 as the LCM. 1 minus 3, which is minus 2 upon 2. 2 to cut and we get minus 1. Common difference D is denoted by minus 1. Next, example 2. Which of the following list of numbers form an AP? If they form an AP, write the next two terms. Here the list of numbers are given, means the sequences are given. They are not already the APs, but sequences means the list of numbers form an AP. We have to check. To check it is a AP or not, we need to find the common differences. The first is 4, 10, 16, 22. It is list of numbers. Given list of numbers, four, 10, 16, 22 up to infinite. It is not an AP. We have to subtract two consecutive terms. A2 minus A1, 10 minus 4 is equals to 6. A3 minus A2, 16 minus 10 is equals to 6. A4 minus A3 is equals to 22 minus 16 is equals to 6. Here the common difference between consecutive terms are equal. Here A2 minus A1 is equals to A3 minus A2 is equals to A4 minus A3 is equals to 6. Therefore, given list of numbers form an AP. If it is form an AP, write the next two terms. Four terms are given. Next two terms means a fifth term and a sixth term. To find a fifth term, we have to add common difference D to its fourth term. The fourth term is 22. And here the common difference D is equals to 6 is equals to 28. To find the sixth term, add D to the fifth term. 28 plus 6 and we get 34, the next two terms. Now the second one. The second is 1 minus 1, minus 3, minus 5 up to infinite. It is a list of number. The first of all write given list of numbers. 1 minus 1, minus 3, minus 5 up to infinite. Now we find the difference of consecutive terms. A2 minus A1, minus 1 is equals to minus 2. A3 minus A2, minus 3 minus A2 is again minus 1. Minus 3 plus 1 is equals to minus 2. Yes, two differences are equal. Compulsory find the next one. A4 minus A3, where A4 is equals to minus 5 minus of minus 3. Minus 5 plus 3 is equals to minus 2. Here the consecutive differences are equal. Here A2 minus A1 is equals to A3 minus A2 is equals to A4 minus A3 is equals to minus 2. Therefore, given list of numbers form an AP. To find the next terms, four terms are given, fifth term and the sixth term. Fifth term is obtained by A4 plus D, where A4 is the minus 5 and the common difference is minus 2 is equals to minus 7. A6 is obtained by A5 plus D, where A5 is equals to minus 7 and add D which is minus 2 and we get minus 9. Minus 7 and minus 9 are the next two terms of an given AP. The third one. Third list of numbers minus 2, 2, minus 2, 2, minus 2 up to infinite. The first write the given list of numbers minus 2, 2, minus 2, 2, minus 2 up to infinite. Find the difference of the consecutive terms. A2 minus A1, 2 minus of minus 2. 2 plus 2 is equals to 4. Third term minus second term. Third term is minus 2. Minus second term is 2 is equals to minus 4. 4 and minus 4 are two different numbers. Here, difference of the consecutive terms are not equal. A2 minus A1 does not equals to A3 minus A2. Therefore, given list of numbers does not form an AP. The last fourth number, if it is not an AP, there are no need to find next two terms. 1 1 1, 2 2 2, 3 3 3 up to infinite. Given list of numbers, 1 1 1, 2 2 2, 3 3 3 up to infinite. Find the difference. A2 minus A1 is equals to 1 minus 1 0. A3 minus A2 is equals to 1 minus 1 is 0. A4 minus A3 is equals to 2 minus 1 is equals to 1. The common difference for first two are equal, but third is 1. Here A2 minus A1 is equals to A3 minus A2, but is not equals to A4 minus A3. Therefore, given list of numbers does not form an AP. Now again keep in mind one not for the common difference D. D is obtained by AK minus 1, or D is equals to AK plus 1 minus AK, or you can also write D is equals to AN minus 1. Here the two examples are completed. In next session we will go through our new examples.